Hi Siva.
I saw.
So today you are explaining about the gap analysis between linear regression ML model with Python and TensorFlow with deep learning activity for the same car price forecasting model, right? ML model.
Yes. For
Okay. First you
converting
explain the
from
gap, then later on you go back to your activities sheet, explain the TensorFlow related tasks, and later you show the code and discuss about the code snippets of TensorFlow. That is the sequence. You can do that. Okay.
yeah, okay, sir. Yeah.
Right.
So hi, today we are going to discuss about the gap analysis in between the linear regression ML model, where Python libraries are there, and TensorFlow, where deep learning activities are involved. So we will see one by one in where the difference actually in between the both models. So first we will see the algorithm type. So here in linear regression ML model, we are using simple linear algorithm mathematical equation that we already know y is equal to mx plus b. Whereas in TensorFlow deep learning activity, where the algorithmic type has contains the multiple layers, like input layers, some hidden layers, and output layers. And also it will useful for to find the non-linear mapping activities also in TensorFlow deep learning model. Then the difference between these two models, this deep learning captures a complex relationships that linear regression cannot handle the non-linear kind of future activities in linear regression ML model. So if you take an example like this linear regression assumes a fixed depreciation rate. That is one feature. But in deep learning activity, this dynamically will adapt the non-linear activities based on the hidden market patterns by applying the multi-layer neural networks. And it will find the non-linear mapping also in between the features. So that is not possible with linear regression model. Then second one, model complexity. So in linear regression ML model, basically it is a very simple and interpretable model with a few parameters. When it comes to the TensorFlow, so basically this TensorFlow deep learning is a complex with the multi-layer neural networks where the neurons and activation functions are involved mainly in the TensorFlow deep learning. So if we take difference, so deep learning handles a non-linear relationships features a better way, while linear regression model is limited to the linear mappings. So we can't handle the non-linear relationship activities with the linear regression because it is a simple thing, a simple algorithm, linear algorithm, where it is good for the interpretable model, not for the complex multi-layer activity model. So this linear regression considers only the basic features like car age, price, then kilometers. But while deep learning captures a hidden layers, like hidden patterns in between the features, like new features like luxury score of the model of the car, then engine, how much engine in the liters. You will see the hidden patterns also in the deep learning activity. So when it comes to the data handling, so in linear regression ML model, this is basically suitable for a small and a medium data sets, uh, useful, the linear regression ML model. But when it comes to the large data sets, so the TensorFlow deep learning handles this large kind of data sets because it has like multiple neural network layers. So it will very useful for the handling the large kind of data sets efficiently. So the difference is, so deep learning scales better way for the big data use cases, whereas the linear regression ML model is suitable for small and medium data sets. So this example, if you take for the data handling, the linear regression may struggle with a thousand of car listing because it is the suitable for a small and medium data sets. But while TensorFlow deep learning is, it will process them seamlessly because it can able to handle the large data sets as well efficiently. Then feature engineering category, if you take in linear regression ML model. So basically, we are going to select manually feature selection and transformation operations are required in linear regression ML model. But in TensorFlow deep learning, so this activity feature engineering can automatically learn the complex patterns from the data through the different layers, multiple layers in the neural network. So this is the advantage while going through the TensorFlow deep learning activity. So deep learning reduces the human effort in feature selection part. And the linear regression needs a manual selection of features. We need to select a manual way, like car age, then engine of the car. While deep learning automatically finds the hidden patterns because of it has a vast neural network layers. Then when it comes to the training process, so in linear regression ML model, basically they uses normal equation or a gradient descent algorithms for optimization purpose, for hyperparameters purpose. But when it comes to the TensorFlow deep learning, they'll uses a back propagation and gradient descent, and they will uses some uh, optimizers also to improve the model performance in the training process. Then the difference is deep learning uses a more advanced optimizers like Adam. So it is a widely used optimizer in deep learning. Then it will reduce the to minimize the error in the training process. So example, linear regression makes a single step fit model, like a single step fit function where we train the data on data. But while deep learning, it performs a multi-epo. Epo means like a number of iterations for each training. It will happen in the epo. So it will fine tune the with better results by following in the training process by using some optimizers and to minimize the error. So in the performance optimization category, so in the linear regression, this is a very limited optimization techniques we have in the regularization purpose like L1 and L2. But in deep learning, we uses the hyperparameter tuning like dropout and batch processing normalization techniques. We have some techniques in deep learning, so that will give the optimization of the model. So the deep learning offers a better flexibility for optimizations over the linear regression ML model. Then the deep learning uses early stopping techniques, so to prevent the overfitting, which linear regression cannot have that feature under the performance optimization. Then model parameters. In linear regression ML model, basically we have very few coefficients like weightage and intercept by following the linear equation of the algorithm. But in deep learning, we have the multiple neural network layers with the thousands of parameters are involved by following the neural networks. So the difference in between the both of them as a deep learning has a more parameters involved. So it is very useful to make a powerful model. But when it comes to the because we are using so many neurons and layers, so it is computationally expensive in the extensive perspective. So deep learning learns multiple hidden parameters while making the predictions much more accurate than the linear regression simple coefficient. And the loss function. So basically in linear regression ML model, we have the loss function mean squared error, mean absolute error, R square value. Similarly, in the deep learning TensorFlow model, we uses like mean square error, mean absolute error, root mean square error, then R square. And also we have some custom loss functions also we can derive it. So the difference is deep learning offers a more flexibility in choosing and customizing the loss functions when compared to the linear regression ML model. So the deep learning can switch to like mean absolute error or switch convert into the custom loss functions also. So making it a more flexible and adaptable to find the price fluctuations based on the trend of the data. So that we can see under the loss function. So training speed. So here we will train the data on the and linear regression model. So it is a faster training will happen in the linear regression model because of its simplicity of the algorithm built-in functions. But wherein deep learning TensorFlow because it will slower the training speed process because due to like multiple layers are involved. So it has a complex computations need to happen in inside the multi layers. So it will take a more time when compared to the linear regression. So deep learning takes a longer time to train the model, but offers a very good, better accuracy over the linear regression. So the linear regression trains in seconds or even minutes, but while deep learning takes a lot of time, minutes to hours even for better accuracy. If you want better accuracy, obviously you will prefer deep learning models. Then model evaluation. So under model evaluation category, so once we have trained the model, we are going to evaluate with the certain metrics like mean squared error, then R square value, then root mean squared error. Similarly, here in the deep learning also, we are going to see how the mean squared error, mean absolute error, and R square additional metrics, the visualization of the data also. So deep learning providing more evaluation metrics for better insights of the data to take a decision based on the data. So it will give more metrics and more evaluation when compared to the linear regression model. Then model architecture. So model architecture, the linear regression model have a simple mathematical operations that will flat the model by using a linear equation. But in deep learning and the TensorFlow model, we have the layered like one by one after the other layered architecture with the neurons and activation functions. So it has a like multi-layer architecture we have under the TensorFlow model. So the difference is that deep learning models are multi-layered and highly flexible when compared to the linear regression. It is a single equation mathematical model. So deep learning uses in multiple layers to detect the complex and the linear, non-linear relationship of the price patterns also, but that will not we will understand and found it while using the linear regression model. Then hyperparameter tuning. So we need to do hyperparameter tuning activities in both the techniques, but the minimal tuning activities are required in the under the regularization of techniques we have in the linear regression model. But when it comes to the TensorFlow, we have like extensive tuning techniques like batch size, learning rate, then layers. We have many uh, tuning techniques we have so that we can hyperparameter tuning we can do with under the layers. So deep learning requires a more hyperparameters tuning to perform optimally and efficiently. So deep learning uses like learning rate adjustments, so making it a more adaptable and finding the market trends when compared to the linear regression model by following the hyperparameter tuning activities techniques. And when it comes to the scalability, so obviously we have some limited scalability while handling the large data sets by using linear regression model. But using the TensorFlow, we have the highly scalable feature we have. So by taking the GPU and TPU acceleration for the large kind of data sets. So the deep learning is actually designed to scale with large data sets and multiple core hardware also using the core hardware memory, GPU and TPU. So deep learning handles a millions of core listing of data efficiently, while a linear regression model cannot handle that kind of data sets effectively. So that is the advantage of using uh, deep learning and TensorFlow model. And when it comes to the flexibility, we have some restricted about the linear relationship while using the linear regression model. But the flexibility under the TensorFlow model, we can have a non-linear features, and also we can see the complex relationship in between the data features. We can easily analyze and understand using the TensorFlow models. Then deep learning handles a non-linear data patterns a better way than the linear regression model. And the example is the deep learning models have a complex depreciation trends for their futures like luxury score, region specific patterns. So that are going to analyze and find the better way than the linear regression model. And when it comes to the deployment category, so it is a very easy to deploy a simple linear regression model. But when it comes to the TensorFlow, it requires like model serialization and exporting and serving the model to save the model and exporting. So it will require some effort to deploy the model into the any cloud or any migration activity. So the deep learning requires additional steps for deployment activity like serialization, then exporting and model serving into the different environments. So the deep learning requires a model export and serving, but the linear regression can be deployed as simple as because it is a simple mathematical model function. So when it comes to the real world use cases, so obviously this linear regression model suitable for the simple predictions where we have some simple small to moderate data sets. So where we can happily use linear regression ML model, but the data we have the complex or large kind of data sets. Definitely we will choose the TensorFlow model, deep learning activities. So that is best suitable for complex and multi-dimensional data patterns. So that this deep learning handles a wide range of diverse and large scale data a better way when compared to the linear regression model. So that is the limited to the linear regression while choosing your ML use case. Then I will show now what are the tasks involved in the under the TensorFlow model. And also we will see the code review in between the linear regression model as well as TensorFlow model also. I will show now. See here, the both data handling and data pre-processing are also happening, both the models as same. But when it comes to the model selection and training, here make the difference between the two models. So basically, these are the tasks involved in the TensorFlow model. Basically, we are importing the required libraries, like importing core libraries and PyPandas, then importing the TensorFlow libraries for building the deep learning model and importing the scikit-learn libraries to handle to importing some libraries. Then we are loading and preparing the data. So we are loading the data set, then selecting the features in the target variable. After that, we are going to split the data into training and test sets. After that, we are going to do the normalizing the data by following all these parameters. After that, we are going to build the TensorFlow model by initializing the model, sequential model, and adding the input layers one by one, and adding the hidden layers. After that, adding the output layer also to find the target price of the selling price. And also finally, we are going to display the model summary. Then after that, we are going to see the compile the model activity. So where these are the subtasks, like we need to choose the optimizer. Then also we also need to define the loss function also. And also we need to specify some evaluation metrics to compile the model effectively. After that, we are going to see the train the model with the callback techniques, where we need to configure the model parameters also. And we need to add some callback techniques to prevent the overfitting, as well as to save the best version of the model use for the prediction of the car selling price. Finally, we are going to train the model with the data sets which we have splitted our data previously. After that, we are going to evaluate the model also by loading the best version of the model. After that, we are going to make the predictions on the test data set. Finally, we are going to calculate the evaluation metrics like mean absolute error, mean squared error, R square value. We will see the visualization also, model performance, by plotting the actual and predicted prices of the car values. And also we will see the plot in between the loss over EPO, as well as mean absolute error over EPO also. We will see the training validation, how much loss it has there. We will see all these things. So now I will show the difference between the in between the linear regression ML model and TensorFlow, the code review also. Let's go to the yeah, okay. So basically, uh, so here we are importing the sklearn linear model. From sklearn linear model, we are importing the linear regression basically. So after that, we are going to load the train data set by reading the CSV file, extrain CSV, and stored under extrain variable, and by reading the bytrain CSV file and store under the bytrain variable. After that, we are initializing and train the linear regression model. Similarly, like we are taking we are initializing the linear regression model function and storing the under the model variable. After that, we are going to do fitting training the data by using the fit function on the extrain and bytrain. And finally, we are going to save the trained model. Similarly, the same thing like importing the linear regression, training the data, and initializing the and train the linear regression model. The same way we are going to see using TensorFlow model also. Here, the same thing. Like here also, we are going to import the TensorFlow, like for building the neural networks. And here we are importing some sequential model, like sequential. Uh, then from TensorFlow.keras.models, we are importing the sequential, and also we are importing some layers, import dense and dropout, and we are importing this some callbacks also, early stopping and modal checkpoint. These are the similar kind of activities we are importing from like a linear regression model, same way. After that, we are going to load the prepare the data. This is also same in both the activities. Like we are going to mention the file, CSV file. After that, reading the CSV file and store the data variable. After that, we are going to see the future and target selection. So these are the futures I have selected, and this will store under the X variable. And this is the target price, selling price. So this will store under the Y variable. After that, I'm going to split the data for training and testing activities. So where we have taken x train x test and y test variables. So this is the function train test split. So this is the 20% of the data test size and random state equal to 42 for reproducibility purpose. After that, I am going to see that normalizing the data for better performance. So similarly, in linear regression model, we are initializing the model, right? We're initializing and train the linear regression model. Same way here, I am initializing the under step 3, build the TensorFlow model. Here I am initializing the sequential model, where like layers are added sequentially one by one. So the first one is here input layer. So we are adding input layer under the model variable. So this is the dense importing already imported. So this is 64 is a neuron. So this input dimensionality is a we are taking 3 features. So that's why it is corresponding to the value input dimensional equal to 3. Then activation is ReLU. This is a uh, this is the activation function basically, and this ReLU function is nothing but it will it will introduces some non-linearity activities. Then it will allow the model to capture some complex patterns of the data. So for that, we are introduces this function, ReLU activation function. Then after that, we are adding the hidden layers with like 128 neurons. So this is some more complex neurons we are adding with the help of activation, ReLU activation. And here we are dropping the 30% of the neurons to prevent the overfitting in the hidden layer. And after that, we are taking another hidden layer too with 64 neurons. That is slightly like less than the previous layer one with the help of activation value. Then we are also same dropping the 30% of the neurons to prevent overfitting. Then finally, we are taking the output layer. This is the adding the output layer one for price prediction of the target variable with the help of this active linear activation. This is basically suitable for regression models. Finally, we are going to display the model summary, model dot summary function. So basically, this will display the model architecture by including the how many number of layers are involved and also how many number of neurons in each layer has counted, and also it will show the number of trainable parameters also, how many number of trainable parameters are happened, and non-trainable parameters also it will show this model architecture. Similarly, here we have seen this one initializes and training the linear regression model, like model dot fit function for training the X train and Y train. So similarly, that the same thing here in TensorFlow, we are seeing the compile the model. The same activity here, instead of training, here we are compiling the model by choosing the optimizer Adam. So this will this will adjust the learning rate. This optimizer will adjust the learning rate also. Then we are introducing the loss function, mean squared error, and we are introducing the metrics also for evaluation purpose, mean absolute error and mean squared error. So it will compile the model overall, and it will give the this evaluations. Then after that, we are going to see the train the model with callbacks. But in linear regression model, we don't have any callbacks techniques and anything. Here we have something callback techniques. Here we are introducing some batch size. So where batch size is nothing but, so it has the number of samples which is used in each gradient while updating during training process. and we have taken 32 numbers, and epochs is 100, where it is nothing but the number of iterations are occurred through the entire training data set. So this is the number we have taken 100. And after that, uh, I'm using early stopping. So early stopping is the callback technique where it will stop the data when the model stops to improve the model. Then it will automatically stop the model by taking the monitoring value loss, data of the loss, and the patience also equal to 5. This is nothing but so the when the model, whenever the model does not improve for next 5 consecutive epochs, then it will automatically stop training. The model will stop automatically after the 5 consecutive epochs. Then after that, I'm going to check the model checkpoint. So this is also one of the callback technique where my model is saved under the core price model.h5 file name, and save best only equal to true means after the model is trained under the best version of the model, then only it will save under this file the best version of the model during training. After that, training the model. So this is same thing like here, training the model dot fit function extrain weighted, and finally we are saving the trained model. The same thing in TensorFlow. Train the model by model.fit function. We are taking the extrain variable and ytrain variable, then the validation data function through following X test and Y test data. Then epochs, we already mentioned epochs here 100, like number of iterations going through the entire training data set, that is 100. Then batch size, we are already see 32, like number of samples in each gradient during training data. And the callbacks, we mentioned early stopping and model checkpoint. So early stopping will stop the model whenever the model stops learning improvement. Whenever the model stops improvement, then it will take the early stopping point and model checkpoint. So this is for the best model version of the model. We are taking the model checkpoint. So finally, we have trained the model with callback techniques. So after that, this is the data loaded and splitted the training sample and testing sample. And this is the sequential one layer where we have the parameters and input layers, some hidden layers also. This is the total parameters, 16,897. And we don't have any non-trainable parameters. So this is the model architecture. It will show how many number of neurons. This is the data for input layers. Then output is none. This is the parameters for each input layer, and this is the output layer 65. So these are the some epochs while following the training data. After that, evaluating the model. Similarly, we have the evaluating task in linear regression. Same way we are considering under the TensorFlow also. So here again, we are taking from sklearn dot metrics, importing these are the metrics we want to evaluate. And we need to load the testing data, and the testing data we want to evaluate. We want to predict the model. So this is our saved model. But this is the prediction and the prediction model and the text data. So that is going to store under the Y prediction variable. Finally, we are going to calculate the evaluation metrics like mean absolute error, mean squared error, then root mean squared error and R square value. So similarly, the same thing we are going to see under the evaluation of the model. So here also we have already saved the best version of the model. This is the name of the model, and we are loading the best model. by using tf.keras dot model and load model. So that will be stored under best model variable. Then after that, we are going to make the prediction on the test data. Similarly, what we have seen in the linear regression model, same way, we are taking the best model variable dot this best model variable dot predict function on the test data, like test data features. So it will predict and it will store the data and by predict variable of the selling price. It will predict the selling price for the test data features. Then after that, we are going to calculate the evaluation metrics. Similarly, mean absolute error, then mean squared error, then R square value, and the y test and y predicted values. Then it will print all the values. Then finally, we're also visualizing the model performance by plotting the graph, which like actual and predicted prices, and also we are going to considering the subplots also. That is, one is plot the graph loss over EPO and loss over MAE, mean absolute error over EPO. So these are the graphs. Also, we will see.
You're running the program and showing, or what is it now?
Yes, sir. Yes, I will show.
Okay, okay,
It's
okay.
okay. So mean absolute error is not defined. So we are importing the metrics from sk.metrics. So we need to NP is not defined. Okay. We import the numpy module. Okay, yeah, we'll import numpy module. Yeah, import numpy as NP. So we are getting one more error. Plot is not defined. Okay. So these are some defined things we need to map out. Import map out. One second. Training loss. There is not defined. So training the model is completed. Same way, parameters involved. Now evaluating the model. Okay, fine. So these are the model evaluation metrics we got. Mean absolute error 68,725. Then R square value 0.96. That means mean squared error. So this is somewhat little big number we got. And root mean squared error also is something relatable 90,000. So these are the predicted and actual values. And these are the loss, training loss and validation loss over epoch. So this is the training and validation loss are almost similar way when it comes to the following over epochs training of the data. Here, a mean absolute error also is following the validation in absolute error and the training mean absolute error also while following the number of epochs and the training data. Maximum it is some variance is there. So this is all about how we can analyze the data, how we analyze the model predictions using linear regression model and TensorFlow. Yes, sir. That's it about.
Done, right?
Yes, yes.
So now, as per your analysis for the car price forecasting, uh, for large data sets, deep learning through TensorFlow is the best solution. If it is short data with less data sets, then linear regression with Python solution is better, you mean to say.
Yes, because in large data sets, if we use linear, so there might be not finding non-linear future values. That that will give like wrong predicted values.
Right.
So
Okay.
yes,
Yeah. Let me stop recording. This is a good gap analysis, no doubt about that. And in future also, when you give demos, you follow the same procedure to do gap analysis with TensorFlow, with other algorithms or other models. Okay.
yeah, okay.
Right.